Hello, this is Mark LaRochelle from Productive Computing and Productive Computing University. Thanks for joining us on this video. We wanted to share a preview of a lesson from a certification preparation course that we created in partnership with Claris. This free course will show you how to connect FileMaker to artificial intelligence using large language models. You can take this free course and find certification information at Claris Academy using the link found in the video description. Now, the Claris Academy courses are just the beginning. If you want to explore the Claris platform in far greater depth and take things to the next level, we invite you to consider our training at Productive Computing University. There you'll find courses on all aspects of the platform, including FileMaker Pro, FileMaker Server, Claris Connect, Claris Studio, API integration training, and more, delivered from seasoned professionals with decades of experience in the field. See the links in the description to learn more. And now enjoy a preview from this lesson from the Claris Academy course. In this lesson, we learn how to perform a find by natural language. Let's open up the Claris invoice solution, and we'll head over to Clients. Here we'll put a new button to allow the user to do a find by natural language. Let's create a script for that first. I'll go up under Scripts, Script Workspace, and we'll create a new script called Find by Natural Language. The first step in this script is to make sure that we call the Configure AI Account script first. And speaking of configuring AI account, let's head over there now. I'm going to change my model to OpenAI. This allows me to test with a model that's potentially stronger, but one that's still approved by Claris. So then head back to the script we just created, Find by Natural Language. Now that we've configured the account, the next thing we want to do is show a dialog box to give the user a place to type in information they want to find by. So for that, in this simple example, I'll do a show custom dialog. And I'll say enter your find request here, and we'll use an input field option, and we'll do one option set to a variable, and I'll say $prompt so that we can store the prompt across multiple finds. And notice that we have a cancel button here. So as a best practice, I'll do a quick if, and we'll say get last message choice equals 2. We'll quickly exit the script in case the user selects cancel. Now you can also do further validation to make sure that there is a prompt or to validate that prompt in some way. But for now, we'll assume they enter a prompt that will work. Next, we'll say perform find by natural language. We'll choose the account. I changed it to OpenAI, so I'll change it here so that we reference that correctly. The model we want to use at this time will be the GPT-4o model. And just as a friendly reminder, models change all the time. Just keep an eye on the Claris documentation for compatibility. And another friendly reminder, this is the letter O, lowercase o, not to be confused with a 0 or a .0. Those would be other models. This is GPT-4 small case o. It stands for Omni. Next, we can define the prompt, and we'll be using the same variable, prompt. That way we can use what the user entered and apply it here. And then the choice right now is found set. We'll look at these other JSON options in another lesson. We have other options here. We can specify the parameters, where you can set additional parameters for the model, formatted as JSON text. This allows you to provide the model more information and make it contextually aware, and prompt template name. Both of these features fall outside the scope of this course. Then we'll do some error trapping here. If the getFoundCount equals 0, we'll show a dialog, no records found. Okay. Now we just need to assign a button to this particular layout. I think I'll grab a button from the products layout. Then I'll paste it right here. Rename it, Find by Natural Language. And we'll assign it to the new script, Find by Natural Language. And that's all we should need. Okay, let's do some testing. I'll find by natural language here, and I'll say, find all clients in Chicago. Found 101 records. And if you want to see the find that it performed, it's a simple matter of going under Records and Modify Last Find. Note that you can use Command R or Control R for that functionality. So it has two requests up here. I'll go to the first request. The first request says City of Chicago in the main address. The second request is City of Chicago in the billing address. So I'd say that that is an accurate find based on what I asked for. So I could say find all clients in Chicago that are active and push OK there. Now we have 45 in the found set. I'll select Command R on my keyboard and we can see that it's a single request where the main address is Chicago and the status is active. Now the only criticism here might be, would we want to use the main address or the billing address or both in this scenario? Let's modify this again. Find all clients with bill to City of Chicago that are active. Now we have 55. Let's see what it found. I have one request active with the billing address in Chicago. Okay, let's do something else. I'll not use the word find. I'll just say active customers with invoices greater than 200. And we have 284 records. There are two requests. We have active and we have 200. So that's not exactly what I wanted. So let me refine that a bit. Instead of the word with, I'll say that have any invoices greater than 200 and see if that subtle change in my language will change. It did change the find. Let's go see what it did. Active, greater than 200. I'd say that's exactly correct. Let's do a couple more. Phone number that begins with 234. It found Pedal Parts Superior with 234, and the request was 234. Let's find active customers with last name beginning with the letter L. We have 12 records, and our request is L with an asterisk. This is how FileMaker identifies a single character with a wildcard at the end, so any last name beginning with the letter L, and active as the selection. Let's take this to another level. Find active customers for states that border the West Coast. Use the abbreviated state name. Okay, we have 63 records. We have 3 find requests. The first find request is State of California, active. The second one is Oregon, active. And the third is Washington, active. So this is an interesting concept where we're asking it for something that it has knowledge of the world, states that border the West Coast, combined with our own data. That takes finding to a whole nother level. How about this? Find all inactive customers with states east of the Mississippi River. Let's push OK and see what happens there. Okay, it found 99 records. I'll modify the find. And we've got 25 requests. And I have inactive Alabama, Connecticut, Delaware, Florida, Georgia, Illinois, Indiana, Kentucky, Massachusetts, Maryland, Maine, Michigan, North Carolina, New Hampshire, New Jersey, New York, Ohio, Pennsylvania, Rhode Island, South Carolina, Tennessee, Virginia, Vermont, Wisconsin, West Virginia. So I've got 25 states that are east of the Mississippi. I didn't confirm these states. I assume that's correct, that are inactive. So that's a find that would take a long time for a user to figure out. First, they'd have to grab a map. Then they'd have to put all of this data entry in, 25 requests. That's a prime example of where the natural find really excels. However, you'll quickly find that it's very easy to add a request that the model has no idea what to do with, and you'll either have blank records or some form of an error. But if used correctly and within certain guidelines, you might find this as a compelling way to add powerful search capability for users who can articulate what they want, but have difficulty creating the multiple requests in FileMaker to perform the find. Now, there's one very important aspect to how this script step works. It does not send any of your FileMaker data to the AI model. it does send the database schema relative to the layout you're working with. It understands the table name, the field names, and the relationships that appear if there were any portals on the layout, but it does not send any data. Instead, it uses the schema and interprets the appropriate find based on the schema alone. To recap this lesson, we learned that the various models you might choose may increase the quality of the find. We learned that the prompt will greatly affect the results. Changing one or two words here or there can make a big difference. It may be a good idea to train users on how natural find works and align their expectations, showing them both how powerful it can be, while at the same time understanding the possible limitations. We learned that this feature excels at advanced finds, and it can interpret prompts and provide multiple find requests. And finally, we understand that this script step only sends database schema and no actual data. I encourage you now to experiment with this, either in the demo file directly or in your own system. If you want to take your knowledge further, consider enrolling in a course or a course bundle at productivecomputinguniversity.com. Details and links are below in the description. Thanks for watching.